Hello, it's Scott Manley here, and if you've been paying attention to space news this week, then you've been hearing a lot about OSIRIS REx and its close encounter with the asteroid Bennu. Some places have called it touching the surface, others called it a landing. Some people said it was booping the surface, and some said it was punching an asteroid, but being the professional that I am, I prefer to describe it as blowing a raspberry on the belly of a 4.5 billion year old asteroid. And that was really the culmination of OSIRIS REx's mission at the asteroid Bennu. So OSIRIS REx, its main purpose was to go to an ancient carbonaceous chondrite asteroid. Carbonaceous chondrites are asteroids which are very, very old. They have unprocessed material from the very earliest part of the solar system. If you find a rock on the surface of the Earth, that rock might have material in it from when the Earth formed, but since then it's been melted, spat out of a volcano, weathered, metamorphosized, perhaps gone back into the crust and then back into the mantle and maybe come up again, right? It is not pristine material, but carbonaceous chondrites, they're very dark, they're full of carbon minerals from low oxygen environments, and it looks like it's believed that these objects are relatively unprocessed since the earliest part of the solar system. So they're very important to understanding how the solar system formed. So OSIRIS REx launched to one of these, was named Bennu, and it arrived in December of 2018. It spent about a year looking at the surface, trying to find a target that it could sample. And well, they had a slight problem because when they originally looked at Bennu as a candidate, they thought, based upon the thermal spectra, the thermal inertia, that this was probably had a lot of particulate material, and it would be like going to a sandy beach where they could just grab a chunk off the surface. It was completely wrong. It was full of giant boulders sticking out all over the place, and they had to work very hard to find areas on the surface they could sample. Not only that, but because of these big boulders, they actually had to change the way they planned to navigate the spacecraft during the sampling. Originally, they were just going to use LiDAR to tell them when they were close to the surface. And with that, they figured they could get within 25 meters of their sample site, and that would be fine. When they looked at the sample sites, they realized they would need precision of about 5 meters, or they ran the risk of hitting boulders nearby. And one of the boulders next to one of the sites was christened Mount Doom, because it would have spelled certain doom for the spacecraft, had it actually hit it. So they actually performed a software upgrade on the spacecraft to give it optical navigation capabilities where it could look at images from the camera, identify important features and track those to make sure it was on course. So during the sampling procedure, when we were watching it live on NASA TV, we could only see a simulation of what was going on. They had been rehearsing this several times. They had the data, they had the images, but the live data coming back from the spacecraft was only 40 bits per second. So it was tiny breadcrumbs telling us how fast it was going, how accurate it thought it was. The reason for this very low bitrate is when it's focused on sampling the surface of the asteroid, it's in an orientation to reduce the damage to itself. It doesn't care about pointing the high gain antenna at the Earth. It cares about making sure that it can sample the asteroid. So after we got the messages that it performed the sampling, and it had headed off into space at a blistering rate of 40 centimeters per second, which may sound slow, but is in fact greater than the escape velocity of the asteroid in question. After that, it was able to, of course, reorient and beam the images back to the surface of the Earth, and we then saw the next day this glorious sequence showing the spacecraft descending, touching the surface, and then, well, as I said, blowing a raspberry. And this was probably one heck of a raspberry. It could have blown maybe a ton of material out of this asteroid in the end. Now, the way the sample container works is it's a disc-like sample object, and it blows nitrogen around the outside in a ring, and that's supposed to go down, and some of it expands outwards, but some of it expands inwards and forces material up into the center of the collection system. And from there, it's blown outwards through vents in the side. And on the way to that, it hits grills, but it also passes through a flap. It's a disc, actually, a mylar plastic disc that gets pushed out as the atmosphere is blowing, and then once that's stopped, it's supposed to flip back and seal all the material they've got in there. And they were wanting to get 60 grams of material. That was their sort of minimum for success. Now, I didn't make a video after these images because I was waiting to find out just how much they thought they had. One of the plans was that they were going to take the camera and hold the sampling device up to the camera and take some images and see, does it look like it has anything in it? And boy, does it have something in it. It has possibly way more than they expected. It looks like when they touched the surface, they went and pushed the sampling head inside the asteroid, and they got a lot more than they bargained for. When they started taking these images of the sampling head, they noticed that there was a lot of particles floating around it. And as they examined it more, they noticed that the mylar one-way disc was open. So it was actually being propped open by some large object, a few centimeters across. These were jammed in there by the force, by the gas. And because this was open, that meant that material was able to leak out, and every time they were moving this sample head around to get a new orientation, they would be imparting kinetic energy to the particles, and those were bouncing around and some of those were escaping. So while they might have a kilogram or more of material, they're slowly losing it every time they move this. The original plan was to weigh this canister, and the way they would do this was to put the canister out on the end of the longest arm position and then rotate the spacecraft, and from that they would be able to determine the moment of inertia of the system and therefore how much it had changed from having mass in there. Now, because they see that they likely have a fair amount of material and that they're losing it whenever they're moving it, they've decided that they're going to cut that out, and they are reprioritizing the entire set of operations to try and put it into the sample return canister as quickly as possible. So on the side of the spacecraft, there is a re-entry vehicle, a sample return capsule. It will hinge open, and in there's a receptacle where they can latch this canister onto it, put it in place. They will then have to detach it from the sampling arm. And this is not a trivial operation because there's mechanical joints here, and there's electrical connections, there's gas connections that they have to cut. So all these things will be severed once they're sure that it's latched in place. Pull that back and then close the container. Now, there are concerns because there's a lot of material floating around that they might try to push it in and find that there's a chunk of rock that's getting in the way. They might try to close the sample return capsule and find that there's debris that's getting in the way there. So they are not out of the woods right now. They need to get this and stow it, and it's going to be a slow operation. The faster they move, the more material they're going to lose. The slower they move, the more time they have to lose material. They're trying to figure out how to do this quickly and slowly at the same time, which is not something that you normally have to do. Some other interesting numbers that came out of this, by the way, was that when the sampling canister hit the surface of Bennu, they registered a very small acceleration in it. What they didn't register was any flexure. There's a spring on the arm that's supposed to absorb shocks, and this spring depresses at a force of 70 newtons. Right, that's about 7 kilograms, 15 pounds if you're in still speaking imperial. So this hit the surface, and that did not register. So they didn't get more than 7 kilograms of force pushing them back. So they hit the surface, and while there's an acceleration, it's less than, it basically doesn't change the speed of the spacecraft. So this hit the surface at 4 centimeters per second and kept going into the surface for about 6 seconds. Then they light the thrusters and it starts to come back out. And they reckon that it might have gone as far as half a meter a couple of feet inside the interior of this asteroid. So, yeah, that's great. They had a lot of material to sample. The asteroid is made of very, very loosely connected material that is it gets pushed out of the way. There'll be a lot written about this, and there's a lot of data coming back, but hopefully there's a lot of material coming back. But it's going to be a while before they get this. They had planned that they would, return to the asteroid a little, but at this point, they haven't performed any burns to stop. They've basically cancelled any further operations until they get this stowed. And so by that point, they're done with this. They're going to be long gone from Bennu. So this is their departure from Bennu, was them blowing a raspberry on the surface. And at this point, they're all saying, "So long, Bennu. Thanks for all the gravel. We'll see you later." Well, we won't see you. Well, hopefully we won't see you later, because Bennu. One of the reasons why Bennu was chosen is because its orbit regularly brings it close to the planet Earth, which means that getting to it is pretty easy in terms of delta V, and getting back is relatively easy because it regularly comes close to Earth. But that also means it has a chance of hitting Earth. So, so hopefully we don't see Bennu up close later at any future time that I'm going to be around for. Either way, look, it's great to see OSIRIS REx has got this material. I'm hoping they get it in the canister, and I can't wait to see it return in 2023. It's going to streak across the sky, and there's a good chance I might actually be able to see it, in my part of the world. It's going to land in Utah, but it'll be coming up from the southwest at very high speed and hitting the atmosphere. It'll get captured in the air. Oh yes, it'll be so exciting. But yeah, OSIRIS REx, marvelous mission. Hope that they manage to get this back. Hopefully they don't run into any extra problems. But that's it. See you in 2023. I'm Scott Manley. Fly safe.